Thank you. So my name is Suho Shin, and I'll present our paper, Ad Auctions for LLMs via Retrieval Augmented Generation. She's joined with Mohammed and Keivan from UMD, and Sébastien from Global Research. Okay. So our main research question is how we could integrate the ads into the output of LLMs without compromising the content integrity of the quality of the output, such as in a form of direct links to the advertisements. And our main idea is to use the Retrieval Augmented Generation, which we'll refer to as RAG. So the RAG technique is a very well-known, recently introduced techniques in LLMs, and is shown to be very effective in improving the quality of the output, as well as reducing the phenomenon called as a hallucination as well. So in the RAG framework, basically there exists a set of documents, such as articles from Wikipedia or blog posts or some embedded document, including some textual information on some specific topics. And once a user writes a query to the LLMs, then it retrieves top K most relevant documents based on some relevance measures, such as semantic distance from the user's query to the document itself. And then it generates the output after it probabilistically selecting the document proportional to the relevance measure. So we propose a segment auction in which each ad is probabilistically retrieved for each discourse segment, where here the segment refers to either a single sentence or paragraph or even the entire document. So overall, given the advertiser's bids for the auctions, once a user writes a query to the LLM, then our retriever component basically computes the relevance measures for the ads with respect to the given query. And then our segment auction runs in order to determine the winners of the auction, as well as the payment function for the winner. And then finally, LLM generates the output by prompting the textual information of the selected ad alongside the user's query. And then, so this is basically the overall architecture. And if you see the output example there, then you can find that the segment is here defined to be a single sentence. And you can find that each segment includes only a single advertisement. And we further generalize this into multi-ad segment auctions, which possibly allocates multiple ads per segment. Yeah, so to precisely define our mechanism, we define the ad score to be the bid times relevance, which is QI times BI. And we want our mechanism's allocation function to be having an allocation probability proportional to QI times BI for every ad I. And in order to do that, we randomly perturb the ad score QI BI by using some Gumbel noise, which is inspired by the discrete choice methods in economics. And then we run a second price auction for a single ad segment auction and probably a generalized second price auction for multi-ad allocation. So assuming that our retrieval component is calibrated so that the expected click-through rate is proportional to the relevance measure, we show that our segment auction is indeed dominant strategy incentive compatible, individually rational, and maximizes an objective function which we define as a logarithmic social welfare, which kind of balances the efficiency and fairness. And we further conduct comprehensive experiments to first quantitatively compare the several design choices for segment auctions, including some multi versus single ad segment auctions. And we kind of further conduct some qualitative analysis to visually see the difference between multiple outputs from the human perspectives. Okay. Thanks for the attendance, and please visit our poster session for more details. Thank you.